Before starting the regular classes of general chemistry, I want you to review some of the basics fundamentals of stoichiometry. Stoichiometry is very important in chemistry, so I would like to give you a brief idea of how it works. Basically, when reaction happens, then it always happens in terms of moles. For example, A plus B, if it gives C, then we need to understand that 1 mole of A reacts with 1 mole of B to give 1 mole of C. If it is 10 mole, then it needs 10 mole to be reacted with A, and it forms 10 mole. So 10 mole of A and 10 mole of B gives 10 mole of C. Now, in chemistry, we will be hearing this term quite often, that is mole. So, what do we understand by mole? So, mole is just a quantity like dozen, right? So, in 1 dozen, we have 12 items, right? Likewise, in 1 mole, we have Avogadro's number of items, or it could be NA number of items, or writing it in values, it could be 6.022 times 10 raised to the power 23, or somewhere it is written 6.023 as well. So this is Avogadro's number of particles. Let me say that I have 1 mole of money. I have 1 mole of dollars. Means I do have this number of mole. From here, it is clear that it is very, very, very more, right? So if I have this much of dollars, then that will be strange, right? Because in trillion, we just have 10 raised to the power 12. This is trillion, and this is 10 raised to the power 23. You can imagine how big a mole is. So why it was introduced? It was introduced to give an idea of how many particles are there. So from here it is clear that let's say in 23 gram of sodium, 23 gram of sodium metal, this is equal to 1 mole. Okay, 1 mole of sodium. It means that 23 gram of sodium will have Avogadro's number of electrons on it. That is 6.023 times 10 raised to the power 23 moles of moles of sodium electrons, and since sodium has 11 electrons on it, so it would be just this number of particles times 11. So this is very important. And another important property is that 1 mole of gas contains 22.4 liters. Any 1 mole of gas consists of 22.4 liters. This is also important parameter that I want you to review. Now, whenever there is a reaction, that reaction always happens based on the limiting reactant. Let me take the previous example once again. So I say that A plus B gives C. If it is 1 mole, then it reacts with 1 mole to form 1 mole, right? If it has 5 moles, then it reacts with 5 mole to give 5 mole. But what do you think would happen if it has 5 mole and B is 10 mole? How much C would be formed? The answer is it would form 5 mole, because this 5 mole would completely react with B, 5 moles of B, and would produce 5 mole, and there will be remaining 5 mole of B. This is the concept of limiting reactant. So the A was initially a 5 mole which got finished because it had 10 moles of B. So 5 moles of A could react with only 5 moles of B, and then the amount of A is adjusted, but we do have remaining moles of B. So here limiting reactant is A, something that is used up first, and it limits the reaction. And while determining the value of this component, we should always consider limiting reactant for determining the amount formed for the product. I hope this makes sense. Now, in order to illustrate this, I do have an example problem for you. So let's solve that. Here I have I2 is produced. I2 molecule or I2 gas is produced by the reaction of 1.5 mole of CuCl2 according to the following equation. So CuCl2, this is given as 1.5 moles or 1.5 mole plus 4 Ki gives 2 times Cui plus 4 KCl plus I2. How many molecules of I2 are produced? So in one molecule, in 1 mole, there would be 6.022 times 10 raised to the power 23 molecules, right? So molecules. Likewise, we do have, let us first find out how many moles of iodine would be produced. So if it was 2 mole, it simply means that 2 moles of CuCl2. 2 moles of CuCl2 would produce 1 mole of I2, right? So we can write 2 moles of CuCl2 would produce 1 mole of I2. But in our problem, we just have 1.5 mole, right? Therefore, 1.5 mole of CuCl2 would produce 1 over 2 times 1.5 1.5 mole of I2, right? So this would be 1.5 divided by 2, that is 0.75 moles of I2. So 1.5 mole of CuCl2 could only produce 0.75 moles of I2. Thus, now when we have moles of I2, and we know that 1 mole of I2 is equals to this number of molecules, so 0.75 moles of I2 would be 0.75 mole would be 0.7 times 75 times this value. I hope this makes sense. Now after that, we have mass of I2 produced. So we need the mass of I2. So we know that the I2 produced is 0.75 moles. Now we need to find mass in gram. So in our statement, we have 1 mole of substance consists of mass of molecular weight. So first of all, we need to find molecular weight of I2. So for finding out molecular weight of I2, we can refer to periodic table, and if you see closely here, then it is somewhere here, that is 126.90447. So that is for I. So in molecule it would be 2 times this value, so it would be 2 times 126.90447. So this would be the molecular mass for iodine, I2, that is 2 times the atomic weight convenience. So this would be 2 times 27, so this would be 254. So the molecular weight of I2 is 252. So after we have that, we know that it was 0.75 moles. So it is times 254. So on calculating value 0.75 times 254, we get our answer. So when calculating it, we get it as 190.5 grams.